This is not our first exploration of intelligent transportation systems. Last time, our feet were firmly on the ground. Today, we're looking up. If you've ever found yourself stuck in traffic, staring at a sea of brake lights, wishing you could lift off and fly over it all, you're not alone. The dream of flying cars has fascinated us for decades, with George Jetson's Space Cruiser being one of the most iconic examples. That brings me to today's guest, an expert in urban air mobility who not only knows the depths and heights of this emerging field, but also reminded me that George Jetson, were he real, would be 3 years old this year. I'm thrilled to welcome Bob Johnson, principal at Johnson Consulting and Advisory, to the podcast. Hi, Bob. Thanks so much for joining me.
Thank you, Matt, for having me today.
Tell me a little bit about your experience and what Johnson Consulting and Advisory's work is in urban air mobility.
I've spent over 40 years building critical infrastructure in telecom and railroad, utilities, and aviation. I've worked with companies such as Electronic Data Systems in Dallas and also in Cupertino in Silicon Valley. I've been with Norfolk Southern Railroad, MCI, and General Motors and Southern Company in Atlanta. Basically, what Johnson Consulting and Advisory does is we help cities, airports, OEMs integrate infrastructure into what we call the NAS, which basically means the national airspace. So we've got this new sector called AAM that we'll get into in a little bit, but basically that's where I help companies such as commercial real estate companies add AAM to their portfolio to see how they can fit in with urban planning, with airport planning, with public acceptance, and go from there.
So it sounds like there's a lot of moving pieces with urban air mobility. So at a high level, what exactly is urban air mobility?
Great question. Let me first start by defining what AAM is. Advanced air mobility is basically moving people and cargo. Now, this is defined by the FAA, moving people and cargo to areas that are served and unserved by aviation. So then we go down one subset down to urban air mobility. The best way I could describe it would be air taxis. Basically, it's short, frequent flights that will get you hops. Think about urban air mobility, think about Uber, that these are flights that are one day, not today, but one day will be on demand. Okay, so think of it as a third layer of transportation. Think of it as a complementary layer that will help the trains and the planes and the automobiles.
So would you say it's sort of like a square rectangle situation where UAM is a subset of AAM?
That's correct. And with urban air mobility, again, that is going to be the short hops. You know, we're not looking to go 300 miles. We're looking to go 30 miles to beat the traffic, to make up time. What are the symptoms of what we're trying to do here? What are we trying to fix? What problems are we trying to solve? And a lot of people will say, well, that may be traffic, that may be time, that may be pollution, all these things that we're working on that we're trying to fix with UAM.
Great. So if we're making these short hops, where are we taking off and landing from? Because that's where every flight starts, is on the ground. So are these taking off and landing anywhere, or are there specified places where this needs to happen?
Today, we're using existing infrastructure. Now, if you want to go back in time, from a transportation standpoint, back in the first realms of transportation, we used canals, and then we moved to railroads. And then the Wright brothers came along and invented the airplane, and then the propellers came, and then the jets came, and then the helicopters came. And now we have what we call eVTOL, eVTOL, which stands for Electric Vertical Takeoff and Landing. The way I would suggest that is, if you're familiar with some of the old cartoons from the Jetsons, we're in that age right now. As a matter of fact, I think George Jetson is 3 years old this year, if you go back in time. So we've got the OEMs that are building these beautiful aircraft that go this way and go that way. vertical and then horizontal, but we need somewhere for them to land and take off. So we've got to have the infrastructure that we call vertiports. In today's beginnings, we will be using existing infrastructure, which will probably be located at our airports around the world, around the country, our general aviation airports. And also we'll be moving into what I call the CBD areas, which would be the central business districts. So we're going to be having airport to the central business districts, but as we evolve, as we get better, there really won't need a place for what we call today in transportation, a hub and spoke. We'll be doing point to point. So we won't have to go wait in a terminal to fly to where we want to fly. We're not there yet. This is a very neo sector, but we're getting there.
So you think some of the earliest use cases will be airport to business center and sort of like a taxi to and from airports?
Yes, exactly. We're looking right now, those will be the first use cases. Now, there's a lot of talk right now of what's going to be first, whether it be passenger service, whether it be cargo service, or emergency medical services, EMS. I think what you'll see as the first use cases will be probably the cargo. I think it will probably be, let's ship some, let's say, components that we can fly at night, we can fly over people, and we can fly over water. The same thing be with emergency medical services. We might be using eVTOL as a first responder. So instead of taking the accident people to the hospital, let's bring the doctor, the first responders to where this bad accident happened. So passenger is very common. I think you'll see a lot today. We've already, a lot of people don't realize this. There are 3 OEMs in the United States right now that are testing with the FAA for certification to make sure this happens. There's a company that has already flown passengers from Long Island, New York into JFK. Now, this was a demonstration. There were 4 passengers and 1 pilot. So it's being done today. You'll hear a lot about what's going on in the Middle East with UAE and some of the companies, even from the United States, that are flying over there. And the same in Japan and Asia. But we know that we want this to be safe. I will be the first to say that technology is always ahead of regulations, and safety does not have a destination. So maybe the tech is 7 dog years ahead of regulation, but we want to make sure that it's safe and that people are wanting to do this.
Yeah, absolutely. And so from a passenger perspective, what might they see when they walk into one of these vertiports? Like, is it going to be like a traditional airport? Is it going to be an extra terminal at an airport? And also from the vehicle's perspective, what sort of infrastructure will these vertiports need to support these eVTOLs?
Great question. I think if you are on the internet quite a bit, you'll see a lot of these beautiful renditions of these beautiful airports and these pods, these pads where they're landing. Again, starting off, it's going to be at existing infrastructure at the airports. A lot of the fixed base operators at the airports, what we call FBOs, is where this is going to happen. The purpose of the vertiport is not to have people hanging around and ordering and waiting and drinking their Joes and their Coca-Colas or whatever, Dr. Pepper, whatever. It's to move people. We want to get them in and we want to get them out. Because in order to make money in this sector and to order to generate revenue and make it of value to people that are using this, we've got to scale. And starting off, it will be a little slow because we want to make sure we have it right. When you walk into a vertiport, I think the word that I will look as far is that it will be frictionless. In other words, there probably at this point won't be a TSA. We'll probably know your biometrics at the time. We'll know if you're a good person or a bad person, or maybe do we need to talk with you before you come inside the gate. All that will be determined And the reason that being is that this is, as I said earlier, this is an on-demand type application. So the vertiports, will they be public or private vertiports? The public vertiports will come first. The private vertiports, it's going to be a little bit before those happen, but it's going to be very nice in a perfect scenario. If you're buying a ticket and you want to go see your grandmother and you're flying from Dallas to San Francisco, let's say, we want you to be able to pick up your iPhone, pull open the app, and start from A and end in Z, and that will get you from your house. You will be picked up by an Uber or ride share, taken to the vertiport. Vertiport will take you to the airport and vice versa. So we want you to be able to do that with one payment and one app, and we want to make it as easy as we can for you.
So the ideal seamless use case sees UAM as part of a broader set of transportation solutions to kind of fill those gaps where current solutions aren't serving customers.
That's a great way to put it. I think the word I like to use is complementary. Maybe an eVTOL is not the fastest way to get to the airport. If it's not, then by all means take the ride share. But we think, when we figure this out, and we're figuring out now on where the airspace is and what the times are.
We've talked a lot about the ground infrastructure. Let's talk about the eVTOLs themselves. So I think the biggest question is, how are these vehicles different from the helicopters we already have in the skies?
Well, let me first say that eVTOLs are not replacing the helicopters. There is a big need for helicopters and what they do. However, on the other side, let me say with an eVTOL, there's great strides in efficiencies from electricity that's being used compared to gasoline that's being used. In a 407 helicopter that carries 4 to 6 passengers, you're probably going to be spending 45 gallons an hour. I will tell you, an eVTOL aircraft, there was a OEM up in Oshkosh a few weeks ago, Beta Technologies, did a demo in front of the crowd for about 15 minutes and used $1.42 worth of electricity.
Wow.
So those are some big things that you're looking at. One of the major things that we try to do from a sector is that we want to educate the public on how this works. And there's a thing that we call sound signature. How loud is it? What are the decibels? Is this going to interfere with my house? Is this going to upset my dog? Fly neighborly kind of stuff. For the demos that I've seen, with a helicopter, you're going to hear it before you see it. With an eVTOL, I think you're going to see it before you hear it. So there are a lot of things that go into play with moving parts. And just a regular jet or airplane, you go out to the runway and you sit on the tarmac waiting for your time to go on the runway. Biggest thing that people found amusing was, in an eVTOL, you go out to the end of the runway or you're at the vertiport and you cut the engine off. And when it's time to fly, you cut the engine on. Those are some of the major things that we're looking at right now. And of course, there's other things to do that we can get into with airspace and how we manage that.
Yeah, and I'm glad you mentioned the power efficiency aspect, because I think that's one of the most important things, because we have battery-powered cars these days, and a lot of them are heavier than their combustion counterparts, but it doesn't matter too much if they're sitting on the ground. But once you get in the air, you have all these size, weight, and power considerations. So can you talk a little bit about the engineering trade-offs with putting batteries in the air?
Basically, we're looking at a flying iPhone or a flying data center in the air. That's what some people have referred to it. And they're lithium-ion battery, but they're very good for short bursts. So they're for 50 to 40 miles, basically. So again, getting back to the vertiports, we're able to have grids that are going to charge these batteries in a fast charge mode. Just like our EVs and our cars today, yeah, we can charge them overnight at our homes if we have the 110 or 220 outlet. But, if we're on the road, we want to make sure that we have those filling stations full of electricity. So, it's one major difference with EVs on the road and EVs in the air. You can pull over on the road. You can't do that in the air. It's not safe. So we want to make sure that we have the adequate supply of that. Now, coming with these batteries, there are some challenges that we have. One thing is thermal management. You look at an ICE engine in a car. If that car catches on fire, the degrees of temperature will probably be about 1,500 degrees. With lithium-ion batteries, as we know, it's going to be hotter, and that can get up anywhere to about 3,500 degrees. So you see a lot of these batteries, it's like we can't put it out right now. We have to let it burn out. So that is a major concern in UAM, and we're very cognizant of how do we suppress this if in a case of emergency, in case of a fire. We're working a lot with the fire marshals, the NFPA, and to how to make this safe and where to store this energy as well at a vertiport. Because a vertiport right now will consist of about 1 to 2 megawatts. That's a lot of electricity to put just in that, say, vertiport that's going to take up maybe a third or 1/2 of an acre of land. So when you think about that vertiport, you think about it's really 1/2 part aviation and 1/2 part management of the electrical grid. Electrical is a very top subject that we're talking about right now, and we want to make sure that we can build these vertiports. We can make sure that they're in the right place with public acceptance and the zoning and the permitting and the safe places to fly. When we're looking at vertiports, right now, as we talked about earlier, they're existing infrastructure, but a lot of the real estate developers and land use people are saying, hey, I want a vertiport on the top of my building. That's good and that's bad. I would say it's good is that it's in a central business district and we want to go where the people are and we want to go where everyone can make money, that we can scale. But at the same time, you got to remember, if you're putting lithium-ion batteries on top of a building, that could be very dangerous. And the same thing as if we get into new ways of energy, possibly with hydrogen, same as that.
Yeah, 1 to 2 megawatts. That's like a small data center worth of power right there. That's a lot. Is there plans to pull it from the grid power or generate some on site?
Now that's a good point. You talked about that's a small data center. 1 to 2 megawatts can light up anywhere from 700 to 2,000 homes in a city. That's a lot of electricity. So we want to make sure that we build these. We've got over 7,000 utilities in the United States right now, a lot of power grids. And if you understand utilities, I used to work for one in Atlanta, that they don't build something where there's not certainty. So we want to make sure that if we're going to put that vertiport in that location, we'll have to build a substation in order to get that amount of electricity in. And again, these take time. You have to get it qualified through the FAA first to build it, and then you have to get the zoning and the permitting. And if you think about it, the last person that will sign off on a vertiport is not the FAA, it's not the mayor, it's the fire chief, because he's the one that has the final say-so. So we want to make sure that we have that grid. It's very expensive to move electricity. Right now, to move electricity, it costs about $1 million per mile. So we want to make sure that we have it in the right place at the right time.
That wraps up this episode. Be sure to join Bob and I next time as we take a deeper dive into the world of eVTOLs. In the meantime, explore more engaging content from Mouser's Empowering Innovation Together series at mouser.com/empowering-innovation.